The human species faces two major challenges. One is population. We have a growing population on this earth. We're at 7.8 billion now. We're likely headed to somewhere possibly as high as 11 billion by 2050. And we need to feed all these people on the earth. Our current agricultural system is not sustainable. So our second big challenge is addressing climate change. And part of addressing climate change is consuming less fossil fuels, releasing less CO2 into the atmosphere. But a big part of addressing climate change in the future is going to be taking all that excess CO2, that greenhouse gas, and pulling it out of the atmosphere. Woody plants are an ideal mechanism for doing that. This is an experimental hazelnut orchard that we started in Oberlin in 2011. These are hybrid hazelnuts, highly biodiverse. They're taking carbon out of the atmosphere and fixing it in the wood of these trees. So every year they're adding wood, and that wood, depending on what you do with it, could potentially be stored for a long period of time. And since this is an experimental system, we're actually trying a couple different approaches to taking that wood and putting it in the soil. One thing we've done is to chip this wood and then just apply chips to the soil. So those chips will decompose over time. And some of that carbon, when they decompose, will go back into the atmosphere. But some of it will become part of the soil that doesn't break down very easily and sticks around for a long time. Another approach is to take those twigs that we've taken off and turn them into charcoal. This process of taking organic matter from plants and turning it into charcoal is called creating biochar. The material created when you burn this in the absence of oxygen. When you make biochar, you take out most of the organic matter that is very easily broken down by microbes. That stuff gets burned off, and so what you're left with is a charcoal material that doesn't have a whole lot of nutrients for microorganisms to break it down and turn it into CO2. And so what you're left with is a carbon material that is likely to stay in the soil for up to thousands of years. One of the ways that trees are managed in a hazelnut orchard is every few years, when they become big, they get coppiced. What coppicing means is cutting them off at the base, right down by the roots, and then allowing them to regrow from the roots. It's just part of the way hazelnuts are grown. Once these get to be well overhead and we feel like it's time to cut them down again, to let them resprout again, we'll cut this down at the base, tie this material into tight bundles, cut it up into sections that are small enough to fit in a biochar reactor. Awesome. So what we're going to do now is go ahead and weigh these before we burn them. .0. You got to be able to get that top on tight. And we have a specially designed device called a persuader. The biochar reactor basically consists of an inner cylinder and then an outer cylinder. And the inner cylinder is the cylinder in which we place the material we're turning into biochar. And we put a sealed lid on that. So a little bit of air can escape from that, but oxygen can't easily get in. And then in the outer chamber, we build a fire. And when we build that fire, it heats up the inner chamber and will turn the woody material in there. First, it'll start to gasify the volatile organic materials in there. and release combustible gases, and that will heat up that inner chamber even more, so that basically all of the stuff that can burn, that can sort of be turned into gas, is turned into gas, and what you're left with is that charcoal material. All right, so when we put this thing in, we're going to flip it so this part where air can leak around is on the bottom. And the objective is we don't want oxygen to get in here. We want the material in here to burn in the absence of oxygen. So by flipping it upside down, what happens is as this chamber heats up in there, it's going to start to release gases out of the bottom here. And those gases, they're going to include hydrogen and methane. Those gases are going to come around the side, and they're actually going to be what causes the latter part of this to burn. So we start the fire outside first, and then as this heats up and gases get released from that wood in there, it's going to ooze out the sides and create its own burn on that. The particular biochar reactor that I built was built out of a 50-gallon drum, so I use that as my inner burn chamber there. And for the outer burn chamber, turns out that a 100-gallon natural gas tank, it's about 2 or 3 inches wider all around than the 50-gallon drum. So you can fit a 50-gallon barrel inside with enough space around it to build a fire. And so we built holes in the bottom to allow for air exchange, a big stack on top to allow for convection of currents around there. So it's a very homemade design for that. I think it's unique. I've never seen a biochar reactor exactly like that one.
We're gonna push the newspapers down using a stick later, but the newspapers really start igniting the fire and making sure that the bigger pieces of wood catch.
So these are old cedar shingles that came off my house, and nothing burns better, nothing starts a fire better than old cedar shingles. Better. If we think about biochar as a piece of a larger solution to climate change, we're kind of beginning to get into these issues of ecological design. The field of ecological design is generally interested in how can we solve multiple ecological problems at the same time, and societal problems and economic problems. How do we sort of stack functionality? So the biochar reactor I built has one function, and that is to turn woody material into charcoal. It produces a lot of heat. That heat is wasted. Ideally, if you were building a commercial biochar reactor, you could do a couple things. If you heated up that inner chamber, you could actually capture that combustible gas coming off and store that gas. That gas could be used for cooking. It's mostly methane. There's methane, a little bit of hydrogen gas in it, but basically it's the same materials in what we call natural gas, which is basically what's coming off of it. So that gas could be captured and used for something. Or you could create a biochar reactor which was designed to take all of the heat coming out of it and use it to heat building. Now, one thing you would also have noticed is when you're looking at the smoke coming out of that biochar reactor, there are periods when that smoke looks kind of ugly. It's full of particulate matter. The solution we've come up with here is a solution that's focused on generating biochar for the experiment. That reactor does not have the kind of EPA controls to clean out the particulates in that. So that's not a design that I would encourage other people to use on a broad scale. I'm quite sure that on balance it's carbon negative, meaning we're creating more carbon that will be stored long term in the soil than we are emitting into the atmosphere. When you scale these things up, you need to make sure you're stacking all of the functions and not solving one problem in a way that generates other problems. Ideally, if we get this right on a large scale, we are both sequestering carbon from the atmosphere and increasing the fertility of the soil.
Yeah, it takes two people.
Not sorry, I'll tip it over.
You can see inside, all of the wood and newspapers are completely burned off. Now it's just some ash that's left over.
Here, I'll handle this and you loosen with that. Okay. Big reveal. All right, take a look in there. This little orchard here was installed in 2011, and we really had several objectives. Biochar actually adds a lot of fertility to the soil. It enhances what we call cation exchange capacity of the soil. The cation exchange capacity of a soil is the capacity of the soil to hang on to nutrients in a way that then they can exchange that with the plant roots. So by adding the biochar to the soil, we're actually substantially increasing the fertility of that soil. In theory, that biochar should break down much, much more slowly than these wood chips, and in the end, we should end up with much, much more carbon stored in the soil with the biochar than with the wood chips. It's kind of a radical approach to agriculture where for now 10,000 years, human beings have gotten into this habit of turning the soil over every year, and that actually has a lot of negative consequences to soil erosion, to soil fertility. And moving towards a system where we keep the soil covered and keep the organic matter, the nutrients, fixed in place in the soil. So it's got a lot of advantages, and it's going to take a lot of changes within the whole economics of agriculture, the way we think about agriculture. But if we're trying to look for a sustainable relationship between human beings and the rest of the natural world, perennial agriculture, agriculture that does not involve turning the soil over, and woody agriculture, agriculture that involves growing substantial amounts of grain-like materials on trees, that is nut production, is almost certainly going to be part of a sustainable future for humankind.